Here we're asked to solve an equation that has an x raised to the power of 4. And at first glance, that kind of worries me because we haven't learned anything for how to solve something that has an exponent of 4 on it directly. However, when you look closely at this, because there's an x to the fourth, an x squared, and a constant term, you can make a substitution of u is equal to x squared. U squared would be x to the fourth. And if we do that, we can see that this is actually a quadratic form. So x to the fourth is like having something squared, minus x to the second is having that thing, minus 12 is equal to 0. And then from here I can figure out what u is by either using the quadratic formula, or if this factors, I can factor the left-hand side. This does factor pretty nice to u minus 4 times u plus 3 is equal to 0. And that tells me that when u minus 4 is 0, u itself has to be 4. And u plus 3 is equal to 0 tells me that u has to be negative 3. So we've solved for u, but the original problem was asking us to solve for x. And because of that, I need to keep going. I'm going to substitute back in x squared for u. Over here, I know that u is equal to x squared. That means x squared is equal to 4. If I take the square root of both sides, x will be equal to plus or minus the square root of 4, which is plus or minus 2. Doing the same thing on the right-hand side, u is actually x squared. This has to be negative 3. If I take the square root of both sides, x will equal plus or minus the square root of negative 3. And here we see that we're going to get a couple of complex roots. This will be plus or minus the square root of 3. And the square root of negative 1 is going to give me an I. So there's 4 solutions. There's 4 solutions. They are, I cannot draw a curly bracket here. There we go. 2, negative 2, the square root of 3i, and negative square root of 3.